Woo! Page 19, number 92. Read the question and come back. Okay, so the ask of the question is to find the area of this shape. Now, one thing you should notice is this shape has more than 4 sides. Anytime we're looking at something with more than 4 sides, you're really stuck with only one formula. And the one formula that we've learned for a shape that has more than 4 sides is area equals apothem times the perimeter divided by 2. Now, this formula only works if you know that your shape is regular. Now, luckily, they told us in the prompt that this was regular. Now, what does it mean when it says regular? Regular means that all the sides and all angles are congruent. So I can mark up in this diagram that all 6 of these side lengths are congruent. Now, let's focus on our 2 pieces of information that we need to get the area. We need the apothem A and the perimeter. They gave us the apothem right here of 5 centimeters. Now, when we draw the apothem, and I'm going to zoom in on this shape. When we draw an apothem, it starts at the center of your polygon, and it's going to be perpendicular to a side, any side. So I'm going to draw one going straight down, perpendicular. When it touches that side length, it's going to touch at the midpoint of that side. So right here, the apothem is crossing at the side's midpoint. That may come in handy when you're not given the length of the apothem, or maybe you're not given the length of a side. But in this case, they gave us the length of the side, or rather, the length of the apothem, and the length is 5 centimeters. So right now, looking at my formula, I have the first piece of information, A. The other piece of information I need is the perimeter. They didn't give me the perimeter right away, but in the prompt, they did tell us that one side length is 8.5 centimeters. So if one side is 8.5 centimeters and this shape is regular, that means all the sides are 8.5 centimeters. So I'm going to label this in as 8.5 centimeters. And then this one again is 8.5. The one on the right is 8.5. The one up top, the one on the left, this side, all of the sides are 8.5 centimeters. So I want to get the perimeter. Perimeter means you add up all the side lengths. So since all of them are 8.5 and I have 6 sides, in order to get the perimeter, I'm going to multiply 6 times 8.5. When I multiply those two together, I'll do it on the calculator to show you. 6 times 8.5, you're going to get 51. So 51 centimeters is the perimeter. It's the length of the outline for the entire regular hexagon. Now, once we have that, we have the 2 pieces of information that we need, apothem, which they gave us, and perimeter, which we just solved for. So let's plug everything in. So we're going to plug in to get the area of any regular polygon. It's going to be the apothem of 5 times the perimeter of 51, all over 2. So in my calculator, 5 times 51 equals, divided by 2 equals 127.5. I'm going to write that down. Area equals 127.5 centimeters squared. Okay, and I'm done. Let me go ahead and make sure that you understand this is only for regular shapes. So if they didn't tell me this was regular, I wouldn't have been able to do it. Only for regular shapes, regular nonagons, regular octagons, regular anything, as long as it's regular, that all the sides are congruent and all the angles are congruent. All right, let's move on to the next question. Number 93. In the accompanying diagram of parallelogram ABCD, find the value of x. Okay, so the fact that they tell us it's a parallelogram is very important. For all parallelograms, we have one important property that has to do with the diagram here. And that property is that opposite angles are congruent. So angle A is opposite angle C. Those angles are going to be congruent, so you can set their measurements equal. Angle D is going to be congruent to angle B. So if we had those measurements, we would set them equal. And that's only because it's a parallelogram. There are a lot of different shapes that are in the parallelogram family. So they could have said parallelogram or any of the kids to the parallelogram family. So within the parallelogram family, we have the rectangle, and we know with the rectangle, well, the opposite angles are both going to be 90, so that's pretty easy to see. Also, we have the rhombus. And a rhombus kind of looks like a parallelogram, except all of the sides are congruent. So it's going to look something like this. And again, we could apply this property. Our opposite angles are congruent. And the last shape in the parallelogram family is the square. A square is kind of a hybrid between the parallelogram and the rhombus. So for your square, opposite angles as well. They're both 90, so of course they're equal. Now let's focus back on this question. We want to solve for x. We know that it's a parallelogram, so we know the opposite angles are equal. So let's go ahead and set them equal to each other. We're going to say x plus 17 is equal to 2x minus 4. Let's start by subtracting x from both sides, so all the x's come to the right. We're going to have 17 equals x minus 4. Lastly, we're going to add 4 to both sides, so we're going to have 21 equals x. So 21 is your x value. Let's just see what would the angle measure be for angle A now that we know that x is 21. So in my calculator, 21 plus 17 gives me 38 degrees. So that means that this angle measure at A is 38 degrees. What about for C? So again, if I plug in the 21, 2 times 21 equals 42 minus 4, I get 38. So both of them are 38 degrees, which is exactly what I want. Parallelograms have opposite angles that are congruent. Okay, let's move on. Number 94. Watch out, there's no visual, so we're probably going to have to draw one. In rectangle ABCD, we have two diagonals, AC, which is 8x plus 4, and diagonal BD, which is 5x plus 16. Find the value of x. All right, so we're just asked to find x. Now go back to the beginning. Let's figure out what shape we're dealing with. We have a rectangle. So I'm going to draw a rectangle. Okay, and now I'm going to label it. So it's called ABCD. I can start anywhere when I start labeling this shape. It doesn't matter. So I'm going to start here at A on the top left, and then I'm going to go clockwise. B, C, and D. Watch as I went in one direction once I've decided that I'm going to go clockwise. I didn't skip around when I was writing my letters. Now they're telling me about two diagonals, AC, which is one diagonal, and BD, and they're giving me values for them. Let's take a look at those diagonals in the diagram. So for my first diagonal, AC, and my second diagonal, I have BD. I have measurements for both. Now, you have to think about, well, what do we know about rectangles and diagonals? In rectangles, what you have to know is that diagonals are congruent. So I'm going to write that down, and you should write it down in your notes. Diagonals are congruent. This is the case for rectangles and also for squares. Okay? So what we can do here, since we're given the measure of both diagonals, and I know they're congruent, is I'm going to set them equal to each other. So I'm going to say that AC is congruent to BD. And now I'm going to plug in their values. So AC is 8x plus 4, and that's going to be equal to the measurement of BD, which is 5x plus 16. Now let's solve. Let's get all the x's to the left. That's where the larger x value is. So subtract 5x from both sides, and we have 3x plus 4 equals 16. Subtract 4. Now we have 3x equals 12. Divide by 3, so x will equal 4. And that's our final answer. So what's special about rectangles and their diagonals? Well, they're congruent. Same thing for a square. Now, in the future, we may have to use one other property that I want to make sure we mention here. And that's that any parallelogram or anything in the parallelogram family, like we mentioned, the rectangle, the square, the rhombus, the diagonals, when they cross, are going to cross at each other's midpoints. So that means, for example, if the left side from D to M were 4 inches, that means from M to B it's also going to be 4 inches. The same thing is going to happen for diagonal AC. Now, since these two diagonals are congruent, I can only make up 4 inches as another measurement for another piece of these diagonals. So I'm going to have to say that MC, for example, is 4 inches. And then AM would be 4 inches. So key here is that they cross at each other's midpoints, right? That's very, very important. So when your shape is slanted like a parallelogram or a rhombus, don't forget that even though the diagonals are not the same length, they still cut each other in half, okay? That they share the midpoint. Okay, let's move on to number 95. Number 95. In rhombus ABCD, you have lengths of AB equal to 2x minus 2 and BC equal to x plus 8. Find the length of BC. Okay, so your ask in this question is to get the length of BC. Not just to get x, but also to plug x in. So let's keep that in mind because we may get all excited, we're going to get x, but we still have to do some work with it. Okay, so we have to plug x in. Keep that in mind. All right, so we're looking at a shape that's a rhombus. So let's go ahead and draw that. So let me go and draw a big rhombus here. Okay, so now my rhombus is labeled A, B, C, D. A, B, C, and D. And then they're talking about AB. Okay, so the measurement of AB. Let's look at our diagram. Notice that AB is one of our sides. So I'm going to label in 2x minus 2 for AB. And then we have BC, which is x plus 8. So I'm going to label in x plus 8. And that's it. So looking at this, since it's a rhombus, one thing you have to know about a rhombus is that all the sides are congruent. So I'm going to put a mark on all the sides, a little tick mark, to show all 4 sides are congruent. Now, if all 4 sides are congruent, that means these two lengths, AB and BC, which are consecutive sides, I can set them equal because they're going to be congruent. So the key for this question, in order to be able to solve, is that I had to know that in a rhombus, all sides are congruent. That's not a great congruent symbol. Let me fix that. Okay, so let's go ahead and set them equal. I'm going to say AB is equal in measure to BC. 2x minus 2 is equal to x plus 8. I'm going to subtract x from both sides. So now I have x minus 2 equals 8. Add 2 to both sides. X is equal to 10. Now I'm tempted to write that as my final answer, but remember we said plug x in because I want the length of BC. So I'm going to take the 10, I'm going to plug it in. So 10 plus 8 is equal to 18. Same thing should go for side length AB if I did my algebra correct. So if I plug it in for 2x minus 2, I'm going to have 2 times 10 minus 2. 2 times 10 is 20, minus 2, 18 again. Perfect. 18 is the length of my side. 18 units. Centimeters, inches, whatever it is, it's 18. Final answer. So the key for this problem is knowing that in a rhombus, all sides are congruent, so you can set any two sides equal to each other. Okay, let's move on. Number 96. The diagonals of a rhombus measure 6 and 8. What is the measure of each side? Okay, so the ask of the question is to find each side of a rhombus. Now, we just did a question that told us that all the sides are congruent. So really, we just need to find one side length, and then all of them are going to be the same. It's a multiple choice question, 10, radical 13, 5, or 4. Okay, let's go back to the beginning. They're giving us the diagonals for a rhombus, and those diagonals are going to have measures of 6 and 8 units. Let me start by drawing my shape. Okay, so here's my rhombus. I know all the side lengths are congruent, so I'm going to put a little tick mark on all 4 sides. And my goal is to get just one of these sides. It doesn't matter which one, any one of them would work. So I'll call the bottom X, and just keep in mind I'm trying to solve for X. Okay, so let's label in our 2 diagonals and their measurements. So for one diagonal, my one diagonal has a measure of 6, and my second diagonal, which is the longer looking one, has a measure of 8. Anytime your shape is slanted, like a parallelogram or a rhombus, the diagonals are never going to have the same length. It's clear to see when you look at the shape that one of the diagonals is going to be longer than the other, anytime your shape is slanted. Okay, now thinking about a rhombus, or anything in the parallelogram family. I mentioned to you 2 questions ago that when your diagonals cross, they cross at each other's midpoints. So what does that mean? That means that the diagonals are going to get cut in half. So for the diagonal that was 6, now, since it's going to be crossed at its midpoint, it's going to be equal on both sides of the midpoint, and the length is going to be 3. For the diagonal that's 8, since the diagonals cross the midpoint, again, the diagonal is going to be cut into 2 equal parts, 4 and 4. Now, looking at my diagram, I'm noticing a 3 and a 4. Okay, that still doesn't get me X. It doesn't get me a side length. Here's the other really important property for a rhombus, and it's also true for a square. Not only are the diagonals going to bisect each other, meaning cross at each other's midpoints, they're also going to be perpendicular. So I'm going to draw right angles at the intersection point. So this is really going to help me, because if I have right angles here when the diagonals cross, I have 4 right triangles. And with right triangles, I could use trig, I could use Pythagorean theorem. I love right triangles. Let's take a look at just one of these right triangles. Let's take a look at this bottom one. I could have looked at any of them. I just chose to look at the bottom. Now for that right triangle, I notice I have a right angle at the intersection point. I have side lengths of 4, 3, and I'm looking for X. Since I have 2 out of 3 side lengths, I can use Pythagorean theorem to get X. So let's use that. A squared plus B squared equals C squared. Now your X value is what you're looking for. That's directly across from your right angle. So the side across from the right angle is what we call C. It's your hypotenuse. So my other 2 side lengths of 3 and 4, I can plug those in for A and B, and it doesn't matter which one's A and which one's B. So 3 squared plus 4 squared equals X squared. 3 squared is 9, 4 squared is 16, which equals X squared. 9 and 16 is 25, which equals X squared. And lastly, and don't forget this step, I don't want X squared, I just want X. So to get X by itself, I have to get rid of the squared. How do you get rid of a square? You square root. So square root both sides. So the 2 and the square root cancel. Square root of 25 is 5. So 5 is equal to your x value. And for those of you that recognize this is a special right triangle, it's a 3, 4, 5 Pythagorean triple. So you would have known right away, oh, 5 is the last side length. So not only is this bottom side going to be 5, all of the sides are going to be 5, because with a rhombus, all the sides are congruent. So our answer is choice C. Now I want to go ahead and mention these 2 important properties again. Okay, so let's go over those 2 properties one more time. The first important property with a rhombus, or really with anything in the parallelogram family, is that the diagonals cross at the midpoint, at both of their midpoints, so they get cut in half. And the other really important property is they are perpendicular, those diagonals. And that's only for a rhombus and a square. So those 2 important things, they cross at the midpoint and it's perpendicular. All right, let's move on to number 97. Number 97, last one on this page. In triangles ABC and DEF, we're given some measurements here. AB is 4, AC is 5, DE is 8, DF is 10, and the measure of angle A is equal to the measure of angle D. Which method could be used to prove that the 2 triangles ABC and triangle DEF are similar? So remember, this symbol, the single squiggly, that means similar. You're trying to prove 2 triangles are similar. There's only 3 ways to prove triangles similar. And here are the 3 ways before we get started. AA, which says you have to have 2 pairs of angles congruent between your 2 triangles. SSS, which says that all of the side lengths need to be in proportion. And lastly, SAS, which says that we have to have 1 pair of angles congruent, and then the side lengths that make that angle included need to be in proportion. Okay, so let's take a look at what these triangles look like. Let's put in the information and let's see which of these will be the appropriate proof method. Now, I don't know what these triangles really look like, but I'm just going to draw 2 random triangles with different sizes. Here's my first one. And my second one, I'll make it a little bit bigger. And this is just to remind myself they're not congruent, they're similar. And now let me label them. If I'm going to start labeling them, I can start wherever I want when I start labeling the first triangle. And my first triangle is ABC. So I'm going to label it A, B, C. My second triangle, though, has to match up with ABC. Since A was written first, then D needs to match up when I draw my visual, because those are going to be corresponding angles. Okay, they're going to be matching angles. So A and D. Next, B is listed second and E is listed second. So those need to match up, and I want to do so visually as well. So I'm going to put E at the top. And lastly, C was written last, third, and F was written third. So those match. So I'm going to put F on the right. Now, let's look at some of these measurements. AB is equal to 4. AC is equal to 5. DE is equal to 8. DF is equal to 10. And then the measure of angle A is equal to the measure of angle D. So, but I put an arc for A and an arc for D. Now, let's go through our proof methods. AA requires that you have 2 pairs of angles. We only have 1. We don't have the second, so we can't use AA. So going through your answer choices, you're crossing out A. That's incorrect. Next, SSS requires that we have all 3 pairs of sides. We don't have the third pair of side lengths. We don't have BC, and we don't have EF. So we can't see if they're in fact in proportion with the other 2 or not. So we can't use SS. So we're going to cross that one off. And lastly, we have SAS. That requires our side lengths to be in proportion and the angle in between them to be congruent. Now, we have angle A and angle D as our congruent angles. So it does look like our first pair of angles is congruent. Now, the two side lengths that include that angle, include it means they're going to be on opposite sides or on the two sides that make up that angle. So for angle A, AB and AC make up angle A. So it includes angle A. For our second triangle, DE and DF make up angle D, so they include angle D. So our side length values are in the positions that I want them to. Now let me check if the sides are in proportion. So I'm going to grab one pair of sides that match, 4 and 8, and I'm going to put 4 over 8. I could have put 8 over 4. It's just a choice. I just want to make sure I match things up consistently. And now the second pair of sides is the 5 and the 10. So since I put 4 as my numerator, when I'm matching up the second pair of sides, I have to put 5 as my numerator over 10. I'm going to simplify this to see if the two side lengths are in fact in proportion. So I can divide top and bottom for 4 and 8 by 2. If I divide by 2, I'm going to put divide by 2. It's not a great little visual, but divide by 2 for the top and bottom. I'm going to get 2 over 4. Well, I can simplify that further. So if I divide by 2 again, I'm going to get down to 1 over 2. So it would have been best in the beginning to just simplify by 4 instead of by 2. Now for the second one, my greatest common factor, because I don't want to have to do with it what I did with the first one, which is go through 2 steps. My greatest common factor for 5 and 10 is 5. So I'm going to divide the top and the bottom by 5. So it's going to simplify to 1 over 2. Now look, we have 1 over 2 and 1 over 2. The side lengths are in proportion. Now what that looks like is 1/2, which is the ratio of the first pair of sides, is equal to the other ratio for the other pair of sides. That's what it means to be in proportion. The ratios of the sides are equal. So it looks like SAS is the way to go. That's the one that I want to use. So if I'm using SAS, let's make sure I select that in my choice. Choice B. The last one here, ASA, that's completely wrong. That's not even an option for proving similar. That's only to prove things congruent, not similar. That's proving triangles congruent, not similar. All right, so you finished page 19. Let's keep it moving.